Draw a picture. So if you're going to draw this, what's a great thing to do to that function first?
Pull out an x.
Yeah, pull out an x. So x times 1 minus x. Why do I do that? What does that immediately tell me?
Yeah, you move it. Yeah.
They're going to be at 0 and what? So you know you're at 0 and let's say 1. Is this going to be concave up or down? Concave down. So it's going to go up and down, and then you're also bounded by what? The x-axis and the line x equals 2?
No, it's around the line.
Oh, line x equals 2. So first of all, there's that one, and then so you have x equals 1, right? So then you need to draw the reflection over that line. So that's going to be starting at what? What is that point going to be?
3.
And what's the next one? So you have x equals 3 and x equals 4, and I can continue drawing this axis. And does it say which one you're supposed to use? Try doing it with washers? Yeah, so you do it with washers first, or you can try doing it with washers and see what happens. You draw the horizontal cut like this, and then once you draw that, you draw the what it's going to look like. There's the hole. Looks like that, right? Is that going to be dx or dy? It's going to be dy, exactly. And it's washer, so it's big R squared. And to give you a little more notation, is it going to be in terms of x or y? Y. It's going to definitely be in terms of y. So it's going to be the big R in terms of y squared, and what do you subtract? The little r in terms of y squared. And what's on the outside? Pi. Pi, because it's washer's pi r squared, right? And then what's the lower? What's definitely the lower one is easy to find. What's the lower limit of integration? 0. Now for the higher one, what do you have to do? Find the vertex. You need to find this height right here. You need this height. So you have to find that height. We have the limits of integration. Now we need to find the big radius and the little radius. So what should you draw if you're trying to find the big radius? What should you actually draw? Draw the big radius, right? So let's go this way instead. So there's your big radius right there. There's big R. To find the horizontal distance, you need the bigger value and you subtract the smaller value, right? What's the smaller value in this case? It's right there. What's it? 2. So it's going to be whatever this value is, subtract 2. That's the distance for the big radius. Do you agree with that?
Yeah.
How do you find the big radius? It's horizontal distance, so it's an x value, but you need it in terms of what? Y. So you have, look, you have, what is it? Y is equal to x minus x squared. Is that correct?
Yeah.
What do you need to isolate? No, you already isolated. You need to isolate x. No, it's not impossible. You can isolate x using what? You now need to isolate x. And you get to this point, and this is where you're going to be very, very, very what? Sad. You're not stuck. You can isolate x. How would you isolate x? Quadratic formula. You can use the quadratic formula and isolate it if you want to. You absolutely can. You can complete the square, do it that way. It's the same thing. Here's the thing. Do you really want to do that? No. So first of all, you have to isolate x. What's the second sign that this is going to be nasty to do? Well, the big R is right there. What other R can you draw in? The little r. There's your little r, right? The big R and the little r are touching the same what? The same function. A sign that it's going to be challenging is that it touches the same function, meaning you're going to have one half and the other. When you isolate x, you're going to have a plus or minus. One of them is going to be the plus side, one of them is going to be the minus side. So you have to figure out which one is which. I mean, you're going to square it, which is helpful, right? But are you guaranteed to have something nice? No. So you have two things, two big red flags. The first one is you have to isolate x, and it's not nice. The second red flag is that both radii, the big R and the little r, both touch the same function. That's another red flag. So you see both of those, and you say, do I have another way of doing this? Yes. What's the other way? Shells. Should you try shells? Yes. So if we were to use shells, what's that general formula for shells? It's going to be 2 pi from a to b, right, of the, now when you draw the shell, and I'm going to draw it on the same, I'm going to draw a mini version of it because I don't want to draw the whole thing. You have two things that look like this, right? And there's your x equals 2. When you draw one of the cylinders, let's just draw one of them. Here's the cylinder I'm trying to draw. Is this going to be a dx or a dy? It's going to be dx. The thickness is going to be a part of the x-axis. So you need so it's dx. The reason I'm saying that is because you need the radius in terms of x, and you need the height in terms of x, and it's dx. So now we did washers, and what happened when we did washers? Sad face. So now we're doing shells. In this case, what's the height? The height is actually pretty straightforward. What's the height of the function? No. It's a function in terms of x. What is it? X minus x squared. You have r of x. Not, sorry, h of x. Sorry, excuse me. That's the height. That's the height. The radius, kids, remember, this right here is your axis of rotation. What's that x value? X equals 2. The radius is the distance from x all the way to 2. There's your radius right there. So what's your radius in terms of x going to be? It's just going to be, not 2 minus x. We're going to the right. It's going to be x minus 2. You're going from x to 2, where x is to the right. What's the distance from x to 2? X minus 2. What's the distance from 5 to 2? 5 minus 2 is 3. What's the distance from 7 to 2? 7 minus 2 is? So what's the distance from x to 2? The reason I'm not writing it as 2 minus x is because I'm taking the values to the right of this function, right here. Now hold on. I just thought of an error. You're totally right. I thought of an error here. The function we have x minus x squared, where is that function? That function is right here, correct? It's to the left of it. I took the reflection, so in fact, so if I was looking at the right-hand side, which I'm not, what should I do instead? It's not going to be x minus 2. What is it going to be? Yeah, thank you for seeing that. Thank you for seeing that. So, I mean, this was, again, what do I say to do every single time? Draw the picture first. I was a little sloppy and I drew a poor picture, and that led me to look at the wrong side. Could I write a function for this quadratic right here? And could I rotate it? Sure. Is it going to be the exact same volume as if I rotated this one? Absolutely. Absolutely. So it's 2 minus x. Okay, so let's plug it in. What do we get? We get 2 pi from what to what? That's the big question now. So it's going to be from 0 to what? 0 to 1, because those are the x-intercepts. Right? You see this point right here? What's that point right there? That's 0, 0. And what's this point right here? 1, 0. So we're going from 0 to 1. And again, what's r of x? Oh, it's, well, not r, it's h of x is going to be x minus x squared. And what do we multiply it by? 2 minus x squared dx. 2 minus x, thank you. 2 minus x. So here's the question. The next question is going to be, oh, and it's just freaking out now. That's really helpful. 2 minus x. Is this something you can integrate? X minus x squared times 2 minus x? Absolutely. What do you have to do first? Just multiply it out. Just multiply it out. So do that for me right now. Multiply that out and integrate that for me right now. Pi over 2. Do you agree with that? Okay, I have 2 questions for you. First, can you do this on your calculator? Take out your calculator, do it right now. That's how it looks on mine. If you do it on a TI-83, you're going to have fn int y1, comma x, comma 0, comma 1. And you should get that right there. You should get the same thing. The decimals might be slightly different because is your calculator actually doing the integral out algebraically? No, it's doing an estimate. It's doing a really accurate estimate. Is this a much nicer integral? Yeah, it's a much nicer integral. So if you do this one out, again, it's 2 pi, and you're going to integrate from what to what? Is it dx or dy? Dx. 0 to what? Square root of pi. That's actually nicely chosen for it. Well, it's nice. And what's the radius going to be? It's rotating around the y-axis, so what's the radius? No. The radius is just x. What's the height? Sine of x squared, and it's dx. Now, is this something you can do by hand? Yeah, what method do you have to use? U-sub, but it works out really nicely, right? The other one does not. Go to lunch, 12:05. We're going to use U-substitution mainly because that's the only method you have other than just seeing it and undoing the product or, the power rule. So what should U be? Yeah, and it works out really nicely, right? The du is 2x dx, so dx is du over 2x. So you have 2 pi integral of x sine u. Instead of dx, what do I write? And I'm going to change the limits of integration now. Now we're going to u land, so what should the limits of integration be now? 0 to pi, because you're squaring the square root of pi. And what's the nice magical thing that happens? Yeah, and also it cancels too, which is kind of cool. That goes away, that goes away, that goes away, and that goes away, and you're just left with pi integral from 0 to pi of sine of u du. Is that about as nice as it gets? Yeah, that's about as nice as it gets. If you see that, you should feel very, very happy with like 2% of dread. You know, if you get things wrong and they look like this, it usually takes talent.
Oh, I knew you stuff. I just like mentally.
You can mentally do it, but I will guarantee you will mess it up 40 to 50% of the time, even if you're brilliant, because people tend to go way too fast on U-substitution. 0 to pi. And I like to factor out the negative, so negative pi. So it's cosine of pi minus cosine of 0. What's cosine of pi? -1. And what's cosine of 0? 1. So you get -pi times -2, so the answer is 2 pi.